As the world moves towards greater levels of autonomy, the shipping industry is also adapting to this trend with smart ship technology. Autonomous ship technology, the Internet of Things, and data analytics are modern features that companies and the entire maritime industry strive for. Autonomous technology refers to giving the software a higher degree of freedom in making important decisions after considering various parameters. Data analysis is the backbone of all new technologies, enabling scientists and engineers to extract and gather useful information from vast amounts of data that would otherwise be impossible to analyze. By integrating these functions into the shipping industry, we can improve shipping efficiency, time management, and productivity in these areas. In this video, let's take a look at 6 key innovations that could revolutionize smart ship technology. The Hercules Project. Hercules, or Research and Development of High-Efficiency Ultra-Low Emission Combustion for Ships, is a program sponsored and supported by the European Union. This program aims to reduce the emission of harmful toxins from ships at sea and in ports. Air pollution from ships is a serious problem that needs to be addressed as soon as possible, and it serves the same purpose. This project is supported by 2 of the biggest names in marine engine development companies in the world, MAN Diesel and Wärtsilä Corporation. The Hercules project focuses on introducing new ways and methods to reduce NOx and SOx from ship emissions. Hercules IP will develop new technologies to drastically reduce gas and particulate emissions from marine engines while increasing engine efficiency and reliability, thereby reducing specific fuel consumption, CO2 emissions, and engine life cycle costs. Successive targets were set for 2010 and 2020 for repairs to be available on board. This goal is achieved through interrelated developments in thermodynamics and mechanics of engines with extreme parameters, advanced combustion concepts, and intelligent multi-stage turbochargers, hot engines with energy recovery and blending, methods of internal emission control and advanced maintenance, engineering, new emissions sensors and performance monitoring, adaptive intelligent motor control. Advanced process models and engineering software are developed to support component design. Prototype components are produced and tested. The experimental engine design is evaluated on a test platform to validate the new technology and confirm the achieved goals. Full-scale testing of selected ship systems will demonstrate the potential benefits of next-generation marine engines. The work is divided into 9 work packages with 18 tasks and 54 sub-projects. The consortium includes engine manufacturers, component suppliers, and equipment manufacturers brought together by renowned universities and research institutes, as well as world-class shipping companies. Partners hold 80% of the global marine engine market and are therefore the custodians of the best technology available today. Panama Canal Expansion Project. The Panama Canal Expansion Project, which is said to be the most anticipated and discussed project and will also be very beneficial for shipping after completion, is expected to overcome the congestion problem. The expansion project will allow larger vessels to use the Panama Canal and also hopes to double its capacity by 2014. This $5.2 billion canal expansion project adds a third set of locks to the 102-year-old canal, enabling it to accommodate the new large container ships that now dominate global maritime trade but are too large to handle the original canal locks to occur. The new lock can accommodate the new Panamax vessel, which can carry up to 12,000 containers stacked as high as the 15-story building. The Panama Canal Authority (ACP) initially requested traditional management oversight of the program. Instead, we offer a much broader strategic advisory partnership, and in that capacity, we were selected to support the project. The original canal had 2 lanes, each with its gate. The expansion project adds a third traffic lane by constructing a lock complex at each end of the canal. A lock complex is located on the Pacific side, southwest of the existing Miraflores lock. The other is to the east of the existing Gate-in locks. Each of these new lock complexes have 3 successive chambers designed to transport ships from sea level to the plains of Lake Gate-in and back down. Each chamber has 3 side tanks to conserve water for a total of 9 pools per lock and a total of 18 pools. Just like the original quay, the new quay and the basin are filled and emptied by gravity without the use of a pump. The new quayside occupies most of the area excavated by the United States in 1939 and closed in 1942 due to World War II. The new locks will connect to the existing canal system with new fairways. The new lock is 427 meters long, 55 meters wide, and 18.3 meters deep, and uses a roller shutter door in place of the slanted door or the original lock. Rolling gates are used in almost all existing locks with the same dimensions as new ones and are a proven technology. The new lock uses tugs to position the ship instead of an electric locomotive. As with roller shutters, tugs have been used successfully and extensively for this purpose on the locks of the same dimensions. The AMBIO project. The AMBIO project aims to provide data and methods for a comprehensive assessment of biodiversity and resources at the New Caledonian scale. A large dataset of 3,000 observations covering most of the NC reefs and associated habitats were collected using a no-bait rotating underwater video. In addition, over a large area around the capital city of Nouméa, data on land use and anthropogenic stresses are collected and compiled to produce a unified assessment that takes into account biodiversity, stresses, and protected status. The AMBIO, or Advanced Nanostructured Surfaces for the Control of Biofouling project, was launched to address one of the biggest challenges facing the shipping industry, biofouling. This project aims to combat biofouling by developing new anti-fouling coatings and paints, improving the physiochemical properties of ship surfaces, improving marine fouling prevention systems, etc. Some interesting anti-fouling methods that will be used in the future could be a system inspired by floating seeds and bacterial molecules that help prevent barnacles in ship hulls. The AMBIO project is a collaboration between various disciplines and partners. While disciplines include nanotechnology, polymer science, surface science, coating technology, hydrodynamics, and marine biology, partners represent industry, universities, research organizations, and end-user stakeholders. The AMBIO project succeeded in understanding and developing newer and innovative anti-biofueling methods by developing 500 different nanostructured coatings representing 64 generic coating chemicals at a laboratory scale to assess their anti-fouling and defouling performance. In addition, 15 end-user tests were targeted. Some coatings have been commercialized and others have been studied for further development. He used a surface-sensitive instrument developed in the project to study the properties of nanocoatings and their changes during immersion. Advances have been made in understanding the effect of surface nanostructures on the deposition and attachment of fouling organisms. It develops the concept of ambiguous coating on the premise that a reasonable degree of heterogeneity and pattern in topography or surface chemistry can be more effective than a homogeneous surface. He developed a new method for surfacing nanostructures for applications other than anti-fouling. He understood the relationship between the structure and properties of layers and their biological effectiveness. The hydrodynamic properties of several potential nanostructured coatings were determined. New imaging techniques, including digital holography and surface plasmon resonance imaging, have been developed and applied for the first time to analyze how fouling organisms examine surfaces and how coating properties affect them. It facilitates the exchange of knowledge and technology between partners from different disciplines and between science and industry. New companies and collaborative projects have also sprung up. He filed patent applications for 5 coating technologies and published 70 articles in international journals. In addition, he educates the general public, the coatings industry, and the research community about nanotechnology and its potential to accelerate the uptake of green and sustainable technologies through 531 individual dissemination articles. European Research Project Through Life. The European Union's Through Life project aims to develop and apply new techniques and technologies to increase the service life of ships. In addition, this project also considers aspects such as economy, the environmental impact of shipping, and safety at sea. Therefore, the project hopes to develop and test new approaches for lifetime asset management based on next-generation materials and manufacturing technologies to improve ship efficiency and reduce environmental impact. Calls for projects are published annually, consisting of 2 strands. Environmental, that's funding innovative environmental measures such as water protection, sewage treatment, etc. And also includes nature and biodiversity projects and environmental and information management. Climate, finance climate protection and adaptation projects and climate information and management projects. The approach is bottom-up, that is, project managers are the people who create their projects and need to apply for life funding. Projects to be financed must be benefiting the EU, promote sustainable development, and offer solutions to major environmental problems. Although sea transport plays an important role in the EU economy and is one of the most energy-efficient modes of transport, it is also a large and growing source of greenhouse gas emissions. In 2018, global ship emissions accounted for 1,076 million tons of CO2 and accounted for approximately 2.9% of global man-made emissions. For various reasonable long-term economic and energy scenarios, these emissions are projected to increase from 90 to 130% of 2008 to 2050 emissions, if the influence of shipping on climate change increases as predicted. A global framework for avoiding dangerous climate change by limiting global warming to below 2 degrees Celsius and aiming to limit it to 1.5 degrees Celsius. To date, adequate action has not been taken, either globally or in the EU, to achieve the emission reductions needed for the marine transport sector to contribute to the EU's more ambitious climate change targets. In addition, reducing emissions from sea transport is part of the commitment to reduce emissions across the EU economy under the Paris Agreement. While a global approach to tackling greenhouse gas emissions from international shipping, led by the International Maritime Organization (IMO), would be the most effective and therefore preferred solution, the relatively slow progress at IMO has prompted the EU to take action and come up with new solutions, proposals that sea transport play a role in achieving climate neutrality in Europe by 2050. IMO Global Last. Ships navigating different ocean areas are a major cause of increasing problems related to invasive marine species. With the increase in shipping traffic in recent years, this problem is increasing massively. The Globe Ballast Program of the International Maritime Organization requires proper management of ship ballast water by providing various methods, such as regular tank cleaning, ballast water treatment, preventing ballast tank filling in certain areas, etc. The Globe Ballast Program places special emphasis on ballast water management planning and prevention of ballast water discharge in specific areas. Ballastless vessels have also been introduced to combat the growing problem of invasive marine species. Globe Ballast's primary goal is to help developing countries reduce the risk of water and ship ballast-mediated bio-invasion of waterways. Using tools and experiences developed from the pilot phase, the second phase of the project initially focused on 15 leading partner countries: Argentina, Bahamas, Chile, Colombia, Croatia, Egypt, Ghana, and a few more. LPC interventions have the following objectives, namely to expand the capacity of government and port management, advance legal, political and institutional reforms at the national level, develop resilience mechanisms and stimulate regional coordination and cooperation. Globe Ballast has a significant public-private partnership component. Private sector engagement has been achieved through the Global Industry Alliance and the GIA Fund, formed with key partners from maritime companies. GIA members include shipping giants such as Keppel Offshore and Marine and APL. GIA helped create an award-winning video shot by BBC Wild Vision that offers unique insights into important environmental issues. Also, with support from GIA, Globe Ballast has developed an e-learning course on operational aspects of BWM, available free of charge both online and as downloadable content for seafarers. European Union's Leadership 2015 program. The EU Leadership 2015 program aims to address the challenges facing the shipbuilding industry in Europe. To advance the European shipping industry, the Leadership program will take a systematic approach to addressing various issues affecting the shipping industry. In January 2003, the Commission established the 2015 Leadership Advisory Group. This group is responsible for making recommendations to improve competitiveness in the field of shipbuilding and ship repair. In this notice, the Commission presents recommendations grouped into 8 areas that are critical to the competitiveness of the sector. European shipbuilding suffers significantly from unfair competition from several countries. This takes the form of undercost pricing and detrimental subsidies. The Commission therefore supports the following 3 recommendations from the 2015 Leadership Group, namely, to continue the current EU trade policy, apply the applicable World Trade Organization rules to shipbuilding, negotiate within the organization for economic cooperation and reach an agreement on shipbuilding, and to outline the implementation of existing rules. To ensure that the shipbuilding sector receives sufficient support from the member states for its research activities, the Commission is adopting the rules on innovation assistance in the shipbuilding sector. To ensure that the shipbuilding sector receives sufficient support from the member states for its research activities, the Commission is adopting the rules on innovation assistance in the shipbuilding sector. The shipbuilding sector requires significant financial resources for both construction and operational phases of ships. However, many banks lost interest in shipbuilding. Therefore, the Commission proposes that the European Investment Bank supports pre- and post-delivery financing. Given the risks associated with the foreign exchange market, the Commission proposes the organization of a currency risk insurance system at the European level. In the field of maritime security and protection of the marine environment, KPPU supports all recommendations of the 2015 Leadership Group, strict application of European laws and their international promotion, more transparent, more uniform, more efficient and independent inspections, creation of programs to assess the quality of shipyards worldwide, which also includes new construction and repairs of ships, improvement of ship repairs, the establishment of expert commissions to support the European Maritime Safety Commission and Agency to capitalize on the potential of short sea voyages. The European approach to shipbuilding needs. The naval defense industry does not have the same needs as commercial shipping. Ship owners are aware of the changing ship emissions and smarter fleet management, but are they also aware of the developments in robotics, artificial intelligence, and autonomy will also impact their operations? AI is the new buzzword in the maritime industry. As the shipping industry is undergoing a major transformation on a global scale, artificial intelligence has made things easier by integrating new shipping logistics and communication technologies to further develop business models in the shipping industry. Another important thing for the industry is the use of autonomous ships. Unmanned vehicles crossing the sea will soon become a reality. The main advantage of the seafarers system is the reduction of human error, which will further increase safety at sea. The system will also change the way current cargo ships explore and interact with each other. Thanks for staying until the end of this video. Share your thoughts or comments in the box below, and we'll see you next time.